Shablagoo. All right, welcome to the next class. Trying out some more openings. That was another one. So today we're still going to be in 6.1. We're going to be graphing cosine. Last time we did sine. And maybe 6.2, which is the graphs of other trig functions. We'll see how long it takes. Okay, so we're going to start off by just doing the graph of cosine of x, the same way we did sine of x, and then all the transformations are going to work the same, so that's the nice part. So how do we first get the graph of cosine of x? Well, we start by plugging in these nice angles. So you plug in the 0 degree angle, the pi over 2 degree angle, the pi angle, 3 pi over 2, and 2 pi. So you're plugging in all the corner points basically, although there's not really corners on the circle, but you're plugging in the 4 easiest points that just come from looking at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So cosine is the x coordinate at each angle. So the x coordinate of the 0 degree angle, this guy, that's just 1, and then the pi over 2 angle, 0, the pi angle gets you negative 1, and then 0, and then back to 1. So what you should notice is that these are the same numbers as we used for sine, except maybe like in a different order. So the idea is, in fact, that these points really are the same, but like shifted over a bit. So these are the points we're going to get. Sorry, that's the wrong one. And then pi comma negative 1, and then 3 pi over 2 comma 0, and then 2 pi comma 1 by plugging in those points. So let's go ahead and graph one period. So one period of cosine of x is just how long it takes to repeat itself. So going around the circle once gives you these 5 points, and then after that it repeats itself, so we're just going to do those 5 points. So 0, 1, and again we're going to count by fourths of the period, just like last time. So we're counting by pi over 2's. So 0, 1, pi over 2 gives you 0, pi gets you negative 1, 3 pi over 2 gets you back to 0, and then 2 pi gets you back up to 1. So this is the shape for one period. And then it would repeat itself, so I'll just draw another period of it. It would look the same if you kept going. If you kept rotating around the circle and plugging in those angles that you get by rotating, it would just look exactly the same, except over here, and you can also rotate backwards. Same idea. But we're just graphing one period, so we always just graph this part here. Okay, so that's the graph of cosine of x, one period of it. And then the idea is the same as last time. We just use the same technique. Same technique as last time to graph transformations. And then that'll make our life very easy. So that's what we're going to do. Okay, so let's in fact, sorry, I'm going to zoom in now. So let's start with just already having the most complicated example possible. Because the technique is the same as last time, we can do everything the same, so we could just jump right to the end. So let's try graphing cosine. Sorry. Didn't leave myself enough room. Let's try graphing f of x equals. So we're going to put a number in the front. Remember, that's the amplitude. We're going to put a number here. we're going to subtract or add something on the inside next to the x, and then we're going to add or subtract a number here. And what we're going to do is we're still going to gather the same information. So we need like the amplitude is 2. That's this number here. It's going to go left by pi over 3. And then it's going to go up 2. And that's what this is telling you. And then we need to get the period. It's all going to work the same. So it's 2 pi. That's how long it takes to finish the graph. That's how long it takes to get from beginning to end. But now this 4 and right here is making everything go 4 times faster. So you divide by it to see how long it takes. If you go 4 times as fast, you divide by 4, and you get pi over 2. So then the last step was we get the period, and we cut it into 4 pieces. So we get pi over 8. And the reason we do that is because every fourth of the way until the end of the period, 1/4 there, another fourth, another fourth, another fourth, is where the graph is easy to see where the point is. It's at the middle, the bottom, the middle, and then the top. Whereas if you just picked some random point like here or something, then this is much harder to see. Like, what height is that? But here at the beginning and every fourth, it's very easy to see that the point is at the top, the middle, the bottom, one of those. Okay, so that's why we do that. And then that's all the information we need, and then we can start graphing. So how do we do that? So remember, last time I said don't draw the y-axis yet. First, what do? First, we graph the shift. We shift the middle. So what's the middle? The middle is still going to be 0, 0. That's what we're going to move still. So that's still going to go left, so negative pi over 3, and it's going to go up 2. So this first tick mark is going to be at negative pi over 3, and then I'm going to go up 2, which I'm just going to estimate as being like right here. And that's going to be the middle of the graph. So for sine, we would have put a dot right there because sine starts at 0, 0, and then it goes up. But that's not correct for this one because cosine does not start there. Cosine starts at the top of the amplitude. So actually what we need to do is not actually draw a point, but we need to first get the rest of the sketch going. So that's where we use the amplitude to get the top and the bottom of the sine wave. So in this case, the amplitude is 2. So from this middle guy, we're going to go up 2. That takes me to 4. And we're going to go down 2. That takes me to 0. That'll be the bottom of the sine wave. And then the next step is to make the next marks using the fact that every fourth of the way to the end of the period is either at the top, the middle, or the bottom of the graph. And that fourth we found was pi over 8. So I have to take my beginning and add pi over 8 to it. That's what this negative pi over 3 was. It was like the start at the beginning. So if I do that, common denominator, oh God, what is that? Negative 8 pi over 24 plus 3 pi over 24. That gets you negative 5 pi over 24. So that's the next one here. And then I got to take that and add another pi over 8, but that's already just 3 pi over 24. So just keep adding 3 pi's over 24 instead. So that'll take you to negative 2 pi over 24. Add another 2 3 pi over 24, and that'll take you to 1 pi over 24. So now we know the y-axis is right in between here somewhere, so we can just estimate it like that. And then I have to do 4 marks, so I need 1 more. So plus 3 more gets me to 4 pi over 24. Okay, so then I redraw. So instead of drawing sine, because I'm not doing sine anymore, I redraw cosine, which is this shape. So what that means is I start at the top on the first tick mark, then I go to the middle, then the bottom, then the middle, then back to the top. It looks sort of like a little V. So at negative pi over 3, I'm not in the middle like I was for sine, I'm way up here, at the top of the amplitude. And then it comes down, because that's the only way it can go. It can't go up higher than the amplitude. And then it goes to the bottom of the amplitude on the next tick mark, then back to the middle, and then back to the top. Then you sketch as best you can. Should be a little bit curvy. Try not to make it too many straight lines. Okay, and then that's it. All right, so let's throw in, actually let me stop here and make a second video for the next part. All right, so we're gonna do a couple more examples and we're gonna get a little bit crazy here. We're gonna get a little wacky. So let's use a wacky color like green for this example. So what we're gonna do is we're gonna graph something like this. 4 cosine of, and I've been sticking whole numbers in here. Let's go ahead and let's stick a little fraction in here, 1/4. Let's see if we can handle that. And then go from there. Let's do a minus at the end there. Okay, so let's do this graph. So although it looks weirder because there's a fraction in there, it's not that much worse. We still need the same information. So we need the amplitude is 4. We need that it's going to go right by pi, and it's going to go down by 1. And the period, what is that going to be? It's going to be still, it's always 2 pi divided by that number there, which just happens to be a fraction. But you can think about this as the speed of the wave is 1/4 as fast as it used to be. So now that means it's going to take 4 times longer to finish. It's going to take 4 times longer to get to the end. And that's why when you divide by 1/4, that becomes a multiplication by 4. So you're going to get 8 pi as your period. Okay? So it still works the same, it's just a fraction, but fractions flip over when you divide, so it still works the same. And the last thing you need is to divide that period by 4, and you get 2 pi. So that's the information we need to figure out the graph. So now we can do the graph. All right, so works the same as before. What we're going to do is we're going to do the shift first. So we are going to move everything right by pi, and then we're going to go down by 1. So this will be -1, and that's going to be our middle line for the graph. And then we're going to use the amplitude to go up and down from there by how much? 4. So then we're going to go up 4. So that takes me up to 3. And then we're going to go down 4. So that's going to take me to -5. Okay, so that's the top and the bottom of the amplitude. And then I'm going to make my 4 tick marks after the first one, so there's a total of 5 always. And how am I going to make those? I'm going to take my period divided by 4, and that's what I'm going to add to get to the next 1/4 of the period. So to get to this guy, I'm just adding 2 pi. That takes me to 3 pi. And then to get to the next tick mark, I'm adding another 2 pi. That takes me to 5 pi, and so on like that. Keep adding 2 pi's till you get to the end of the period, which again, one whole period is 8 pi. So from beginning to end should be that distance. And is that true? Is the beginning, is it 8 pi from here to here? Yes, it is. Okay. So now we're ready to graph because we already know that cosine always looks the same. It always looks like this. And so we just have to redraw those dots at the tick marks that we made. So the first dot, the beginning of the graph, is at the top because it's cosine, then it goes to the middle, then it goes to the bottom, then back to the middle, and then back to the top. And then you just do your best to sketch. Try to make it a little curvy. You can even draw these little end things to indicate that you know it's going to keep going. It doesn't just stop. But we're just graphing one period, so that's okay. Okay, so that's it for that. All right, so let's do one more tricky one before we move on. So what other tricks can we do? So let's put a negative in the front because we haven't done that yet. And then what I'm going to do is actually the number in front of the x, I'm going to have a pi already be in it. So let's make this be like 3 pi. And then this thing is not going to have a pi in it. Let's make that be a +2 actually. Okay, so it looks a bit trickier because now there's this pi in there, but we just treat it the same and everything will work out. So this is saying it's going to go left 2 and down 1, and then the period is what? Well, it's still 2 pi divided by the speed of the wave. So how fast is it going? It's going 3 pi times as fast, so you divide by that. And what happens is that the pi's actually cancel, so you get a period that doesn't have a pi in it. And then you take your period, you cut it into fourths, that still works the same. 2/3 divided by 4 is 2/3 times a fourth, which is 1/6. So everything will work the same. It just seems like it might be different. Okay, so then we can graph. Whoops, don't make the y-axis. So let's graph. So let's see, I gotta first of all go to -2, going left 2, and then I have to go down 1. At -1, that's my dotted line. It's my middle dotted line. Then I gotta use the amplitude as 3 to go up and down 3 from there. So I gotta go up 3. So -1 plus 3, that gets me to 2. And then I gotta go down 3. That takes me to -4. And that's the bottom. Let me make that one a little bit lower, actually, just to make it proportional. So -4. So then, how do I continue? I make my tick marks. That's the next step. 1, 2, 3, 4 of them. And here's the trick. I already know how it's going to look. I could draw the dots before I even label the tick marks. So that's something you could do because it's going to look the same every time. But where are these tick marks? They're at the starting place plus 1/6. So now I got to do -2 plus 1/6. That's kind of annoying. What is that? Negative 12/6 plus 1/6 gets me to -11/6. So that's going to be here. And then I'm just going to keep adding a 1/6. So that's just going to be that, and then that, and then that. So the y-axis is actually way over to the right, somewhere over here. You don't even have to draw it, but there it's somewhere over there. Okay, so now we can draw the graph, but there's one thing I didn't talk about, which is this negative in the front flips it upside down. So how does that affect the graph? Well, the idea is that originally cosine follows this pattern, and the negative flips everything over the middle. So what's going to happen is that it's going to become the opposite pattern. So it's going to start at the bottom and then go up and then back down. So that means at this first tick mark here at -2, I don't go up here like I used to. Instead, I go down at the bottom. And then the next tick mark, I go to the middle. And then the next tick mark, I go to the top. And then back down to the middle. And then back down to the bottom. Okay, and then technically it keeps going forever like that, but we'll just draw one period. Okay, so that's it for this example, and this is the end of that video. So there'll be one more video, and I'll catch you over there. All right, so up next, we're going to talk about how to graph secant and cosecant, which sound like they'll be much more scary than sine and cosine, but we actually have all the tools we need to graph them very quickly. So let's look at secant of x first. So the way to graph secant of x is to remember how it's related to either sine or cosine. So which one is it related to? Well, it's 1 divided by cosine of x. So what does that mean if I want to know the points on the graph? So that means, for example, that if cosine of x is 1, then secant of x is 1 over 1, so it's the same thing. So they actually connect. They touch. So when is cosine 1? That's if I plug in 0, right? If I plug in 0, I get 1. So that means when I plug in secant of 0, I also get 1. So they touch. So that's one thing. So what else happens? Well, what about if cosine of x is 0? Well, then something bad happens, because then secant of x is 1 divided by 0. And what does that mean? So that means the graph of secant of x has a vertical asymptote. That's what that means. So when is cosine 0? Cosine is 0 at pi over 2 and also 3 pi over 2. So that tells you that secant of x has vertical asymptotes at these two x values, pi over 2 and 3 pi over 2. So we can start using this information to graph. I guess I should say one more thing. What about when is cosine of x -1? That'll mean secant of x. It's the same as what happens with 1, but so I should have done it earlier, but I just forgot. So the point is that they're both -1 at the same time. That's at pi. So they connect at pi comma -1. Okay, so let's start graphing. So what I'm going to do is I'm going to graph cosine, then secant. So I'll use 2 different colors, in fact. So we know how to graph cosine. It looks like this. So at 0, it's 1, and then it follows this shape here. Okay, so this blue guy will be cosine of x. And then I'll use green for secant of x. So what do we know about secant of x so far? Well, we know that it connects to cosine at this point and at this point. So that's what is that actually saying? That's actually saying that it connects with cosine at the top and the bottom of the amplitude. And then what do we know is we know that there's two vertical asymptotes at pi over 2 and 3 pi over 2. So pi over 2 is here. I guess I should have labeled those. I'll go back and label them right now. 3 pi over 2 is there. So we have those vertical asymptotes. And then what do we know about vertical asymptotes? Well, we know that as the graph approaches a vertical asymptote, as it goes towards it, it has to either follow it up or follow it down. So which one is it going to do? Well, let's think about it. When I plug something in, so what's in between here and here? Let's think about like pi over 4. So when I plug in pi over 4, actually there's a better way to think about it. Let's think about it like this. So I'll do it down here and then we'll go back up and graph. So as cosine of x moves toward pi over 2, that's what's happening here, the blue line, it's shrinking toward 0. And you can see that even on the unit circle. So as the angle goes up to pi over 2, the x value of the points are shrinking towards 0. So that these x values shrink towards 0. So what does that mean? Well, that means that if you divide by something that's shrinking, it's going to get very big. So for example, if you do like 1 divided by a very tiny number, like 1/10, it becomes 10. And then you do 1 divided by an even tinier number, like 1 over 100, it becomes 100. So as this thing you divide by gets smaller, then the overall number gets bigger. So what that means is that secant, so secant of x gets large. So that means if when we go back up here, what's it going to do? Is it going to go down towards 0 like cosine does? No, it's going to do the opposite because it's getting flipped over. It's going to grow very big and follow the asymptote up to infinity. Very, very big. So now what we can definitely say is that the graph looks like this. And the same logic will tell us that over here, as the graph goes towards the asymptote, what's it going to do? Is it going to go that way or that way? Well, it's going to get very, very big again because cosine is shrinking towards 0, but from the negative direction. So it's going to get very big in a negative way. It's going to go down to negative infinity. And then same thing here. And then on this side, it'll just be the same as it was over on the left. So the graph of secant is the green part. But you never want to try to graph it without drawing sine or cosine first. So in fact, that's what we're going to do on the next example. Okay, so to graph any secant graph, first graph the cosine version. That's the key. All right, so here's an example. So graph one period of something like this. 2 secant of 3x plus pi over 4 minus 1. So if I want to graph this, I'm actually going to graph the cosine version instead, and then I'm going to use the above logic to graph the new graph instead. All right, so we're going to graph this guy, which we know how to do. So now we can do it very quickly. The amplitude is 2, the goes left, pi over 4, down 1. The period is 2 pi, divide that by that number there. And then you take the period and you cut it into 4. 2 pi over 3 over 4. That is pi over 6. So that we know how to graph very quickly. Draw the x-axis, draw the shift. So negative pi over 4 down to negative 1. That's going to be the middle. Go up and down the amplitude. So I'm going to go up 2 to take me to 1. And then I'm going to go down 2 to take me to negative 3. And then my next 4 tick marks, 2, 3, 4, are going to come from using this pi over 6. So negative pi over 4 plus pi over 6, that's, what is that? Negative 3 pi over 12 plus 2 pi over 12 gets me to negative pi over 12. Then I keep adding 2 pi's over 12 to get these ones. And then I just draw cosine. So cosine goes from the top down to the bottom through the middle, and then back up to the top again through the middle. So we're experts at this by now. Okay, so then secant, I'll do in green. So then wherever there's the middle, wherever cosine hits the middle, that's where the vertical asymptote has moved to. So it's going to be here at negative pi over 12. Because everything will move together. And then you draw these little top and bottom things connecting to the top and the bottom of the amplitude. So what that means is, just like right here, we drew these little things coming out of the top and the bottom of the amplitude. It's going to be the same here. So let me draw this middle one first. It's going to follow it that way, and follow it that way, follow it there, and follow it there. So then the green part is the graph of the secant version. And that's it. Okay, so now let's do cosecant, and it works the same. So we're just going to jump right to a big example. So let's graph f of x equals, let's do negative even, negative cosecant, so I won't even change the amplitude, it'll just be 1. 3, no, I keep using 3. Let's stick like let's do a fraction one, 1/2 x plus pi plus 1, no, plus 2. Okay, so same idea. Don't graph cosecant. I don't know what that looks like. Graph the sine version first, because cosecant is just a 1 over sine. Okay, so we're going to graph the sine version first, which means we need to look at all these pieces. So the amplitude is 1, because there's no number in the front there. That just means there's a secret 1 there. It's going to go left pi, and then up 2, and then the period is going to be 2 pi divided by 1/2, which flips it over to give you 4 pi. And then I'm going to take that period, I'm going to cut it into fourths to see how far I need to get to the next good angle, and that'll be that. Okay, so then we graph the sine version. So first I do the shift left pi, so that's going to be negative pi, and then up 2. That's going to be my dotted line in the middle there. And then I use the amplitude to go up and down 1. So I'm going to go down to 1 and up to 3. And then my next 4 tick marks, 2, 3, 4, come from adding period over 4. So I'm adding pi to negative pi, that just takes me to 0. So in fact, that's also the y-axis there. And then pi, 2 pi, and then 3 pi. Okay, so then how does sine look? Sine, I start in the middle and I draw this shape, but it's negative. So I gotta flip it upside down. So I start in the middle still because it's sine, and then on the next tick mark, I go down to the bottom of the amplitude. Then I come back to the middle, then I go to the top, then I go to the middle, always in that same pattern. So that's my sine graph. And then to do cosecant, same rules. So that means that whenever sine hits the middle, so when sine hits the middle, that's when your cosecant is being divided by 0. So that means that there's going to be a vertical asymptote, because that's when you're going to have a 1 over sine of x being 0. So you're going to have vertical asymptotes, 3 of them in this period. So 1, 2, 3. And then it's still going to connect at the top and the bottom. And we're going to draw those same shapes. So at the bottom of the amplitude, they connect, cosecant and sine connect, and then they follow the asymptotes. And then over here, same thing. Follow the asymptote after you connect it at the top of it and the bottom of the amplitude. So then the green part is the answer. Okay, so if there's time for a daily problem, do it. If not, then I won't put it on Gradescope. We'll see how long it is. So here's what I would like you to do. Graph this guy. So try this one, -2 secant. So remember the negative is going to flip something over. And then let's stick a fraction in here. Let's do 1/3 x plus, let's move it to the right. Everything we kept doing was to the left. So let's go to the right. And then let's go down 1. Okay, so if there's time, try that. Otherwise, it will not be on Gradescope, and then don't worry about it. Okay, see you next time.